In 2026,
Initiating pickup
solid-state
sequence on the
batteries are
left.
no longer a
Copy that. Right
science
arm
project
syncing now.
headline.
Confirmed.
They're
Throughput
on
is
window
optimal.
stickers in launch events
All right,
and in the
checking the
sales
battery
pitch that's
pack
supposed to
connections
erase
now.
every worry
Everything
people have
looks
ever had
secure.
about
No signs of
EVs.
corrosion.
Fires, slow charging, degraded range, expensive battery replacements. Solid-state is being sold as the clean reset, an EV that finally feels as simple and dependable as a gasoline car, only faster and cheaper to run.
This is
But
our
as these
latest EV
first
model. It's
solid-state
fully
models
charged and
begin
ready.
landing in
Wow, can
real
we try it?
driveways,
Of
a new
course. Yeah,
warning
you
is
can unplug
emerging
it.
for buyers.
Great.
The biggest risk may not be whether the technology works. The risk is what happens after you buy, when ownership collides with warranties, insurance rules, repair networks, software updates, and resale markets that have not fully caught up. This is the new ownership risk of 2026. The battery may be next generation, but the system around it, service, parts, valuation, and long-term confidence, is still being built in real time. And that gap can cost owners money. To understand why, it helps to start with the most important detail buyers often miss. In 2026, solid state does not always mean one clear thing. In its purest form, a solid-state battery replaces the liquid electrolyte used in most lithium-ion packs with a solid electrolyte. That can potentially allow higher energy density, lower fire risk in certain scenarios, and a path to faster charging. But the market is full of halfway steps. Semi-solid designs, hybrid electrolytes, and solid-state inspired chemistries that are improved, but not fully the breakthrough the public imagines. That matters because buyers are being asked to pay for expectations, more range, ultra-fast charging, longer life, without always being told exactly what version of solid-state they're buying. In other words, two cars can be marketed with the same label, yet behave differently in cold weather, charging speed, degradation rate, and repairability. And a confusing label doesn't just affect your satisfaction. It can affect your resale value because used car buyers tend to price what they understand and discount what they don't. The second reality, the early solid-state advantage may be real, but not always visible the way you think. Range is the headline everyone listens for. Solid-state cells can offer higher energy density, which should mean more miles or less weight. But manufacturers also protect new batteries with conservative software buffers, reserving part of the pack at the top and bottom to reduce stress and preserve longevity. The sticker might look great, but the usable capacity you experience day-to-day can be more modest than the hype suggests. Charging is another promise. Solid-state is often paired with the idea of radically faster charging minutes, not half hours. But real-world charging speed depends on more than cell chemistry. It depends on pack cooling, cable and connector limits, charger availability, temperature, and the manufacturer's charging curve decisions. Many EVs advertise a high peak charging number that only appears briefly. Owners care about the time from 10% to 80%, and how often they can repeat it without the car throttling to protect the battery. If a buyer pays a premium for solid-state fast charging, and later learns that charging is limited by software, heat management, or infrastructure, the technology hasn't failed, but the ownership value proposition has weakened. Safety is the third pillar of the sales pitch. Solid-state is often described as safer, especially by reducing the role of flammable liquid electrolytes. That may be directionally true in some cases. But safer does not mean invincible, and early generations of any new battery can introduce different failure modes. Swelling, microscopic cracking, interface instability, performance drops in extreme cold, or sudden changes in capacity behavior. Even if these issues are rare, the public reaction to rare events can be outsized. One viral incident can reshape perception overnight, and perception drives resale prices and insurance risk models. And that brings us to the biggest ownership risk in 2026. Long-term aging is not fully proven in the wild, at scale, across climates. With traditional lithium-ion packs, the industry has years of real-world data. There is a well-understood pattern of degradation for different chemistries, and buyers have learned what to expect at 50,000 miles, 100,000 miles, or after years of fast charging. With early solid-state implementations, there may be less public long-term fleet data. That doesn't mean the batteries will degrade badly. It means the used market may treat them as an unknown. In the car business, unknown equals discount. That uncertainty shows up at trade-in time. Dealers and used car buyers price risk into their offers. If they aren't confident about long-term battery behavior, or if a particular model year is rumored online to be an early pack with quirks, resale value can fall harder than expected. This is not theoretical. The used EV market has already shown how quickly values can swing when buyers get nervous about battery replacement costs or a model's reputation. In 2026, solid state may introduce a new twist. You could own a vehicle that drives perfectly, but the market still penalizes it simply because it is early generation. Warranty language, then, becomes the financial center of the story. Buyers often hear 8-year battery warranty and assume peace of mind. But the fine print matters more than ever with next-gen packs. First, capacity warranties usually guarantee a minimum capacity, often around 70%, by a certain time or mileage. But 70% capacity can feel dramatically different depending on climate and driving patterns. In winter, that loss can turn a comfortable commute into a daily calculation. Second, capacity must be measured somehow. Some brands rely on the car's internal estimate. Others require a dealer diagnostic. If the test method is complicated, expensive, or only available at limited service locations, owners can struggle to make a claim even if the battery is clearly underperforming. Third, some warranties include exclusions tied to usage. Repeated high-power fast charging, commercial use, or operation outside recommended conditions. If a car is marketed on fast charging superiority, but the warranty quietly discourages frequent fast charging, that's a mismatch that can trap owners later. Fourth, software updates can change the product you think you bought. Manufacturers can legally adjust charging curves, reduce peak speeds, increase buffers, or limit certain behaviors to protect longevity and safety. Sometimes that is responsible engineering. But from an owner's perspective, it can feel like performance being taken away after purchase. If that happens widely, it becomes a resale story and a trust issue. The next ownership pressure point is repairability, and it may surprise first-time EV buyers. A battery pack is not just cells. It's a complex structure: thermal systems, sensors, control boards, high-voltage contactors, seals, structural components, and safety systems. Solid-state packs may be built differently from conventional packs, and early designs often have one common trait: limited service familiarity. If your local service centers aren't fully trained and equipped, small problems can turn into long waits. If replacement components are scarce, you can face downtime. If the manufacturer's policy is to replace whole packs rather than modules, the cost outside warranty can be enormous. And even inside warranty, the time without the car can be the real penalty. This becomes especially important when you consider insurance. Insurance companies price vehicles based on claims data. In 2026, there may be limited real-world claims data for solid-state models. When insurers lack data, they tend to price conservatively. That can mean higher premiums, stricter post-accident inspection rules, and more cases where an EV is declared a total loss because the battery pack's integrity can't be confirmed quickly or parts aren't available in time. Even if solid-state reduces certain fire risks, insurers still have to consider repair cost and complexity. If a minor crash requires expensive pack inspections, specialized labor, or long waits for parts, the math can still push cars into total loss territory faster than buyers expect. Then there's the version problem, and it may be the most expensive part of early adoption. Technology is moving fast. A buyer in 2026 could purchase a first-generation solid-state EV, only to see a revised battery arrive in 2027 or 2028 with meaningfully better cold weather performance, improved charging durability, cheaper replacement packs, or a more repairable architecture. When that happens, the market can relabel your car quietly as the old one, even if it's only 2 years old. This is how early adopter depreciation happens, not because your car is bad, but because the next version resets expectations. And there's an additional risk specific to battery branding. If different suppliers or chemistries are used within the same model line, the used market may start asking, which battery does it have? If that question becomes common, it can split resale values the way engine options used to split values in gasoline cars. Owners could find themselves having to prove what's inside their pack just to get a fair offer. So what should buyers actually do in 2026? When solid-state models look tempting and the sales pitch sounds like the end of EV compromise. The first move is to demand specificity. Don't accept solid-state as a one-word guarantee. Ask what chemistry it is, what electrolyte type it uses, and what independent or standardized testing numbers back the claims. If the answers are vague, treat the label as marketing, not engineering. The second move is to focus on charging curves, not peak charging power. Ask for the typical 10% to 80% time under normal temperatures, and ask how the car behaves on repeated fast charges, because road trips are rarely one perfect stop. The third move is to read the warranty like a contract. Look for the capacity threshold, the measurement method, the exclusions, and whether the warranty transfers to the next owner. Transferability matters because resale value depends on whether the next buyer feels protected. The fourth move is to ask about repairs before you need one. Can modules be replaced or only full packs? How many certified service locations are in your region? What is the expected lead time for high-voltage components? In 2026, downtime risk can be as costly as repair cost. The fifth move is to consider ownership structure. If you want the innovation but don't want to carry the resale and uncertainty risk, leasing may be financially safer. Leasing doesn't make the car better, but it can cap your exposure to sudden depreciation if a newer battery version makes yours less desirable. And finally, treat early solid-state cars the way smart buyers treat any first-generation technology. Buy with eyes open, not closed by hype. The breakthrough may be real, but the ownership ecosystem around it is still settling. In 2026, the biggest mistake isn't buying solid-state. The biggest mistake is buying solid-state without protecting yourself. With clear documentation, warranty clarity, repair network confidence, and a realistic expectation of what new can mean for resale value. Because the next battery revolution isn't just about what powers the car. It's about who carries the risk after the purchase, and in this first wave, that risk can land squarely on the buyer.